Alright, we're going live. Give me one more second because I gotta get the chat popped out. And up. And over here. Shit. There we go. And here we are. That's not what I want. Alright, everybody. Welcome to Basic Computer Help. Starting a little late today. We're going to continue on our kernel development series. The last live I had an internet issue after I had, well, other issues. Excuse me. And last week I was sick. We believe it was COVID. I'm still waiting on my test results to come back. But that's neither here nor there. This episode, I'm going to set up the global descriptor tables as well as add more functionality to the UI. Well, it's still going to be a text-based 80 by 25, but I'm going to add more functionality to the UI. In particular, I'm going to be clearing out the screen. Now, if you look in the description below, you're going to see a couple more links to some PDFs, which is to the Intel manual, as well as to a Unix clone development tutorial. I'm going to be implementing some of those codes into our little kernel here. Yeah. I also have been working on a kernel on the side, kind of like testing out different code to see like the direction I want to take our little live stream kernel as well. Also, excuse me, I still got like sinus drainage or something. Okay, let's get to the monitor. This is the code pretty much that I had left off at the last stream. If you look on the GitHub account, you'll notice that I have unsigned shorts and unsigned characters instead of uint16t's. And I have base as a pointer. Now, I took base off as a pointer because we're going to be dealing with this in assembler code and not directly here. Now, if you were at my live stream last week, you noticed that I stopped in the middle and was like, what the heck, something's wrong here, as I started looking through all of my notes. And what was wrong was pretty much my GDT, or my global descriptor table that I had in my notes, was not right. I didn't have it finished, and they were incompatible with other code that was there, which kind of sucks. One question that I've gotten since my last stream was, they found Brian's kernel development tutorial. Is that any good? Back in the day, that was actually really decent, but it's got some pointer issues, and it used a.out, and we're not going to be using a.out. We're using elf. So we don't have to use the a.out clunge, or whatever the heck it's called. Oh, move. And it's not that one I want. Right here. In one of the things that I found was the James Malloy kernel development tutorial. You're going to notice that there is, let me bring it up on the screen. This little code right here. I'm not going to do this stuff right here, primarily because, well, we have our own stuff brought in by system.h. It's an stdint and stddef.h. But we got uint16 underscore t, and I'm going to stick with those. We still need to deal with our in and output ports, which we're going to have to code now. And I'm not going to have them in common.h. Actually, while we're discussing all of this stuff, let's start implementing that now. Move that over. All right, I lost my train of thought for a second. I am going to make a .c, and in here I'm going to include system. There we go. Good, that'll include everything I need. And I am going to put the prototypes in here. Whoops. And we're also going to do our input ports. In B, oops, I want 16 not. And in W. B is for byte, W is for word. And in modern C++, extern is already there, so we don't have to deal with it. Out B. This is going to give us some control over the system. It has to be an assembler, but I hate passing parameters between C and assembler. It's actually not terribly complicated. It's just there's a lot of areas in which that can go wrong. Whoops. Oops. Helps if I spell volatile, right? Now, I'm going to have to give it its, yep, out P. This is an AT&T syntax because we're doing this through gas. I'm not really sure too much of C's inline assembler. Usually when I have to deal with assembler, I just pass the code off to assembly. And there we go. And I'm just going to copy and paste these over because it's going to be exactly the same. I just have to defrag this. 16. Damn it. And we're going to copy this one over. because pretty much in every, I've even downloaded some open source kernels. They're all pretty much written the same way as this one is. So I'm not going to do too much in terms of the way of rewriting this. It works. Yes, it works. And if you ever see it where somebody's doing underscore assembler, whoops. All that's doing is in case you have ASM as a keyword anywhere. So what's going on with all this code? Well, we need inline assembler. That's what the ASM is for. Volatile tells the compiler that it cannot optimize this code. It's going to do a little bit of optimization. It'll try to do a little bit of optimization in for our assembler code, and we really can't do that because the C compiler doesn't normally have to deal with in-B, out-B, and in Word. So we need to tell the compiler that it can't do anything with the code we've put in here. Then we have our assembler. Like I said, I'm not too sure on like the C stuff. I did some reading up on it. But for most of the assembler code, like when I do the GDT flush, you're going to see that I actually write that in an assembler file. That way I don't have to deal with any passing parameters. And I don't want to deal with that. And it's just because you can mess up and screw up the stack, or even screw up one of the registers. And we're going to also add more screen code. I'm going to put and make this terminal clear. And we've got put and we've got write. All right. Yes, I will be basing this off of the code that's on James Malloy code, but he's kind of got a hodgepodge of stuff going on as well. I'm not going to bother with moving the cursor right now until after we've written the GDTs and the ISRs and all that other stuff. Alright. And for this one, let's save that. I feel crazy right now. And for this, we're going to call this one I can't believe I just did that. Actually, I can. I'm not going to copy his entirely. Instead, what I'm going to do is copy the initialization code. I don't need to assign terminal buffer. Alright. Let's save that out. Let's see how that all worked out. First, let me make sure I'm in the right path. I have the appropriate stuff in our path. And I do. Okay, it hasn't crashed. What I am going to do is in our main function. Now remember, it worked perfectly, so if we do terminal clear, should be absolutely nothing. So now we know that function is itself working. Oh, I have made some changes to the run file. Our run script, it's actually pretty simple. Our run script, I just added GTK, wow, zoom to fit equals on, enable KVM, which we won't really notice right away. Our kernel is still very, very simplistic. And I gave 512 megs of RAM to our virtual machine. That way it's not going to whatever the default is for this install. Here that. Oh, right. Alright, let's get ready for the GDT now. We are going to write the global descriptor table, which is going to be pretty hybrid. Ooh, I forgot to mute my phone. Let me put this on Do Not Disturb for 1 hour. Alright. Our global descriptor table is pretty much already set up from last week, or 2 weeks ago. But we have the GDT entry. This is going to be for each segment of code. And in our pointer, this is actually what we're going to put in the register here. We have to pack it because, now this is going to depend on what compiler you use, but Microsoft Visual C adds about 8 zeros in between each of these elements. It's for debugging purposes. And GCC usually adds 4 to 12, depending on if you've compiled for release or a debug. We can't have that. The processor is going to expect that all of our data is going to be right up against each other in memory. So we got to pack it. That's what this attribute packed call does. It says don't pad our structures. Excuse me. Now, if you looked at the online code, you'll notice that base is a pointer, and I've removed the pointer here. The primary purpose is we don't need it to be a pointer. We just need it to be a value of a pointer. It sounds confusing, but it's just the way the processor is going to handle it. I do recommend you go over to the James Malloy kernel development tutorial. Stop that from loading. And look at their code, especially on GDT. There is a lot of theory behind it. I'm going to just kind of brush over it, but we're going to describe how RAM is going to be segmented. In particular, we're going to set up 5 different rings. You have ring 0, 1, 2, 3, and 4. A ring 0 or the null descriptor doesn't really do anything. 1 and 2 are for the kernel, and then 3 and 4 are for user space code. It's a little bit more complicated than that, really. So if you want to see the theory behind it, I highly recommend you over and read all the code. Links are all in the description. But another thing I'm going to do is actually create global variables. One of the ways that he does it, James Malloy does it, is he actually passes it to assembler. Like I said, I hate passing parameters to assembler just because you can accidentally screw something up. Assembly will allow you to do that. But I'm just going to create global functions, but in the C function, in the C class. GDT. GDT. And that's going to be our little array of various different memory pointers. Yes. And inside of, where's our damn header file for it? We do need I forgot I am coding for C99, and we do need to put extern in here. It's not really needed. GCC will imply it, but just for standard's sake. Well, not necessarily standard's sake, but for clarity's sake, I would like to have it in there. Oh, shoot. Let's just get rid of this encode GDT entry. We don't need that. We're going to go a little bit more simple. We're going to just do a set gate. All right. I might as well copy this because I think I'm going to need a lot of these. All right. That's going to be our number. It's going to be base. Limit. Of course. Access level. Granulation. number, base low. I am going to defrag this a little bit. I'm just going to copy this because it's all going to be pretty much repetitive. I've been discussing just making these as like regular YouTube videos, so I edit down all these boring parts. If you're watching this either currently or in the future, let me know which direction you would like me to go with these videos. Especially since I was late today coming in. Cool. Init GDT. I did forget one thing. This is going to be in our assembler file. Oh, excuse me. Ah, I forgot. There we go. We have 5. 4 in the rings and 1 null descriptor table. Now this is where things are going to start to look weird. We need the address of GT. Yep. That'll get us a pointer to the first GDT entry, and that's going to be used by the processor. When we're done with all of this, it might get a little loud, guys. Somebody's running water. Now I'm going to cheat here and actually just, whoops. Alright, now we're going to write our flush GDT code. I'm going to actually just kind of be lazy and add this to the boot thing. Important. If you're on Windows, it's going to be underscore flush underscore GDT. We're not on Windows, we're on Linux, so it's going to have to be flush GDT. I also need to make it global. As well as tell it that I have something external. What the hell did I call that? That way, when I run the assembler, it's not looking for GDT PTR. Alright, that's going to load our GDT pointer and everything else into the LGDT register. That's not what I want. So it'll read all the data out of here, take whatever's in here as a pointer, and then go through all of this and set up the RAM that way. We have one that's already set up. It's set up for us by Grub, but it's not valid. Now we're going to do some weird moves. To our AX register, we're going to load 0x10, which is going to be a location of our kernel data segment. On the tutorial, it says just data segment, but it's actually going to point to our kernel data segment on the GDT table and run off of that. The main parts of our kernel are actually going to be before it, and they're already loaded at this point. But now we have to set up our memory segment. So DS is going to be from AX. See what I mean by some of this is just really redundant. I did FS, yes, now I need GS. Now we're going to do a long jump. A far jump, I'm sorry, not a long jump. Which we're going to return from this. Alright. This should all work. Now we just got to add it to the kernel. Kernel main. I want to initialize that before. Yeah. And then we want init GDT. let's see how we're doing. Yeah, make everything first. We have an assembler error. Assembler line 37. Because I spelled extern wrong. Alright. Well, let's clean this up. Undefined reference to GDT PTR. Oh, this is fun. Undefined reference to init GDT. Hey. Alright, well, let's see. Well, we still have the GDT PTR problem. What did I do wrong? Alright. Let's see now. Did I misspell something? Is it too big? Alright, let's make this clean again. Undefined reference. Okay. Let's move this undefined reference to after the function. If it was that, I forgot that. No. Huh. You know what, let's add all this to its own assembler file then. Urgh. What? Nope, that's not it. It's an assembler issue. Because it's not that. I forgot to tell make that there is a gdt.o and an in out.o What else did I forget? Back kernel main screen, GDT in and out, boots. Yes. Error junk DX after register. On line 13. Oh God. Plain. Error junk dash DX. After register. In out. What did I do wrong? I know I have a working copy. Over here. Let me see what this one is. Hmm. 16 and 8. 16, 16. Wow. That is alright, let's break this down to assembler. Let's see what it's doing. Yeah, well. No S, because this is going to be a GCC assembler file. Boom. Line 13. DX from AL. Alright. Somebody's probably watching this either now or after going, the fuck, it's stupid simple. Is this moron? Junk DX after register. Which gets us here. Oh, it's not here. Ay. This is why I hate doing this by hand, and I should have copied and pasted the whole thing. All good. Alright, it didn't crash and burn this time. And yes, when you're doing any kind of development with assembler, or in this is kernel development, yeah, your error message can be that cryptic. Now you get to watch me figure it out and debug it on the fly. So now we have an entire, our entire global descriptor table is set up. You didn't really notice much. Now we're going to set up something called an interrupt descriptor table. And if. Dumbass. There's a decent amount of theory involved in this one, too. Let me see how my stream is doing. Give me a second. Not too bad. Probably be a little bit better if I wasn't stopping a lot. After I set up the interrupt descriptor tables, there's a decent amount of theory over into this one too, but ultimately we're going to be setting up our timers, our our hardware exception handlers. If somehow you manage to get the processor to attempt to divide by 0, it's going to throw an exception. Yeah. And this is going to look pretty much the same way as the GDT system does. 32. This is going to be 16-bit. Kernel segment selector. 28. Kind of a cheat, but that is actually a it sits in between the base low kernel segment selector and then our flags. And we are also going to set up a pointer for the same thing. And this is going to contain our pointer to the base without it being a pointer. Alright, this is the part where we're going to be doing a lot of copying and pasting. Because we're going to be doing 31 of these. Kind of not really, though. Because this is going to get pretty much on our nerves really fast. No, this is not it. Is it? Yes, it is. copy that. Paste to that. Why is this up? Some I just thought of. I need to have the IDT set gate and the IDT install. Is it 99? No, way more. Oh, God. Add it to our make file. And see if it even compiles first. No. Alright, we're not going to zero out the memory, because because I don't have memset set. Alright, what's wrong now? Undefined reference to IDT load. No problem. Remember, if you're on Windows, you want to start with an underscore. Kind of quick here, huh? Oh, I need to make that global. All good. Let's just make sure it doesn't crash and burn. And we're good. I haven't really loaded anything in yet. I'll save that all for next week. Hopefully next week goes a little smoother than this week. So yeah, leave a comment with some ideas. Do you think I should just shoot these videos throughout the week, chop together, so it's a smoother video? You're not watching me do so much tedious stuff very quietly, because it's going to be a while before we do anything with actual real code, doing anything cool. If you noticed, most of what we did today, you don't even see results for. Or, you know, anything else. Let me know. Keep me posted, guys. Alright, until next time. Next week I'm going to do just a traditional video, see how well that plays out. Yeah. Alright, well, you guys got to watch me debug a problem because I forgot a comma in inline assembly code. And stuff like that. I will be deleting that .s file and pushing everything to the GitHub account. Alright, everybody. Have a good week. See you next week.